Hello viewers, I am Dr. Mala Das Sharma. Welcome you to my channel Chemphilic. Let's start episode number 56 of Teaching Chemistry through Riddle. Here is our riddle number 56, which is an organic chemistry problem based on functional group interconversion and identification of organic compounds. So, let's start riddle number 56. X is a weakly acidic aromatic compound. A neutral functional group can be introduced to X by a well-known name reaction whereby compound Y is formed. The compound Y responds to 2,4-DNP test but not tolerance test. Y undergoes a popular condensation reaction and form compound Z, which is a alpha-beta unsaturated acid. X and Y can form colored azo dye. So this is our riddle number 56. Let's solve the riddle and make the required discussion. So we'll discuss according to the following points. First point, identification of the compounds X, Y and Z. Second point, discussion on the well-known name reaction by which X can be converted to Y. Third point, compound Y does not respond to tolerance test. Reason, what is the reason you have to tell. Fourth point, explanation of the reaction referred here as popular condensation reaction. And fifth point, the reaction by which X and Y can form colored azo dye. Now, let's start solving the riddle. First clue is given, the compound X is a weakly acidic aromatic compound. Therefore, X may be phenol. Now, second clue, when a neutral functional group is introduced to X, that means to this phenol, by a well-known reaction, then compound Y is formed, and since the compound Y responds to 2,4-DNP test, it is given in the riddle, therefore the neutral functional group must be carbonyl group. Now, compound Y, that means in compound Y already phenolic OH group is there and one neutral functional group, that is carbonyl group, that is also there. Now, compound Y undergoes a popular condensation reaction whereby alpha-beta unsaturated acid is formed as per this riddle. Okay. Now, this condensation reaction may be Perkin condensation reaction because through Perkin condensation reaction, alpha-beta unsaturated aromatic acids are formed. Now, Perkin condensation reaction is given by only aromatic aldehydes but not by ketones. We'll tell the reason soon. Now, therefore, carbonyl group present in Y. Y has already OH group, phenolic OH group and another carbonyl group, and that carbonyl group must be aldehyde group, and the compound Y may be salicylaldehyde, where this OH group, that is phenolic OH group, and this aldehyde functional group, they are present at ortho position with respect to each other. Now, salicylaldehyde can be prepared from phenol by a well-known name reaction, that is Reimer Tiemann reaction. It is given in the riddle that Y is prepared from X by a well-known name reaction. So, what is Reimer Tiemann reaction? This is salicylaldehyde. Reimer Tiemann reaction, phenol is treated with chloroform in presence of alkali, and whereby this orthohydroxybenzaldehyde is formed, and to some extent para-hydroxybenzaldehyde also formed. That means CHO group is introduced in the ortho position with respect to the OH group, and to some extent in the para position. So main product is orthohydroxybenzaldehyde or salicylaldehyde. This is Reimer-Tiemann reaction. Now, salicylaldehyde, as it has CHO group, it responds to 2,4-DHP test but not this tolerance test. Generally, aromatic aldehydes, we know it responds to tolerance test, but salicylaldehyde does not respond to tolerance test. Why? Let's see. Here you see in salicylaldehyde, CHO group, OH group, they are in ortho position with respect to each other. Now, tolerance test means alkaline silver nitrate solution. So in alkaline medium, phenoxide ion is formed. Now, this phenoxide ion take part in resonance with this aldehyde group or CHO group. See here, this negative charge will come here, and then this bonded electron pair shifted, so we'll get this resonating structures. And because of this resonance, this CHO group is stabilized, which prevents the other reactions like reactions with tolerance reagent, etc. Now we see Reimer-Tiemann reaction. Already I told what is Reimer-Tiemann reaction. When phenol is treated with chloroform in presence of alkali, salicylaldehyde or orthohydroxybenzaldehyde is formed. That is Reimer-Tiemann reaction. Let's see the mechanism. From this chloroform, this alkali will take this H plus and you'll get the carbon ion. Then one chloride ion is removed and you will get the dichlorocarbene. In dichlorocarbene, this carbon is attached to two chlorine atom and one orbital contains this lone pair of electron, and it has one more vacant orbital because carbon is tetravalent, no? So it has one vacant orbital. Because of this vacant orbital, these carbenes are electrophile. It can accept the pair of electrons. Now, from phenol in alkaline medium, phenoxide ion is formed, and then it takes part. See, this negative charge will form double bond here, and this double bond through this carbon atom here will get the negative charge, that means resonance participation, and this negative charge attacks this dichlorocarbene. Okay, and when it attacks this dichlorocarbene, then this carbon atom gets the negative charge. Okay, and now what happened? This H plus is removed. This H plus is removed means this bonded electron pair will come here, and this double bond, this pi bond will shift to oxygen, and this H plus will be attached to this negatively charged carbon atom. Then what we will get? This is 6H5, then this is O minus, and sorry, this benzene ring, this is O minus, and then here it is CHCl2. Now in presence of alkali, what will happen? This two chlorine atom will be replaced by OH group. So just imagine CH, OH, OH. Now when two OH groups are attached to the same carbon atom, water will be removed, and finally you will get this compound, that is the salicylaldehyde. First here it is phenoxide ion. On acidification, it will form the salicylaldehyde or orthohydroxybenzaldehyde. Now coming to Perkin condensation reaction. Perkin condensation reaction, it is a condensation reaction between aromatic aldehyde and an acid anhydride in presence of the salt of the carboxylic acid, and through this reaction, alpha beta aromatic acid is formed. Okay. So, see, this is salicylaldehyde, and here this one aldehyde group is there. When it is treated with acetic anhydride in presence of sodium acetate, then you see orthohydroxycinnamic acid is formed. This is Perkin condensation reaction. Now, Aromatic ketones cannot undergo Perkin condensation reaction. It is given by only aromatic aldehyde. Why? We'll see the mechanism, then it will be clear. See, here sodium acetate, that is salt of the acid, whereby acetate ion is formed. We have taken sodium acetate and acetic anhydride. Okay. So acetate ion is formed. Now this acetate ion takes this H plus from this anhydride and form this carbon ion to form this carbon ion. Now this carbon ion attacks the carbonyl carbon atom because this carbonyl carbon atom is partially positive charge. Why? Because this oxygen is electronegative. Okay, CH double bond O, no, that double bond pi bond is shifted to oxygen. So this carbon atom is positive. So this carbon ion can attack this carbonyl carbon atom. In case of ketone, here in place of hydrogen, alkyl group will be there. Alkyl group will have plus I effect. Because of the plus I effect, this positive charge is to some extent neutralized. As it is neutralized to some extent, then carbon ion cannot attack easily. So, ketone does not undergo Perkin condensation reaction. So, this carbon ion attack this carbonyl carbon atom and then we'll get this one. And then on hydrolysis, OH and H, this is C double bond O, then OH, that is acetic acid, and then this another hydrogen will be coming here. So we will get this compound C6H5 CHOH CH2 COOH. Now water will be removed. How? This OH group and the hydrogen atom from the adjacent carbon atom will be removed as water and we will get the cinnamic acid. This is the mechanism of Perkin condensation reaction. Now coming to the next clue, that is X and Y can form azodine. Now what is this? Diazonium salts reacts with active aromatic compounds. What is meant by that? Active aromatic compound means when the activating group is attached to the benzene ring, which activates the benzene ring towards electrophilic substitution reaction, like phenolic OH group, amino group, etc. Those are active aromatic compounds. When these active aromatic compounds reacts with diazonium salt, regarding diazonium salts, its preparation and reactions, I have discussed in riddle number 55. You can see from the playlist. Now, when this active aromatic compounds reacts with diazonium salt, then a strongly colored azo compounds are formed, and this reaction is known as the coupling reaction. Now, this is coupling with phenol. This is diazonium salt and phenol, and after coupling reaction, this is para-hydroxy-azobenzene. This is the azo group, N double bond N. And when the coupling takes place with phenol, it occurs at alkaline medium. Similarly, with the salicylaldehyde also, this coupling reaction can take place with this benzene diazonium salt. Now, this coupling reaction is nothing but this electrophilic substitution reaction. You see, this is the phenol. This lone pair of electrons shifted here, resonance occurs, then this pi bond shifted here, and through this pi bond it attacks this diazonium cation. This pi bond shifted here, then you will get this compound. Then what happened? Now this H plus is removed. When H plus is removed, then this pi bond shifted here, then again it shifted here. We will get this azo compound, that is para-hydroxy-azobenzene, where OH group in the para position of this azo group. Okay, so this is the coupling reaction. Now we have come to the last part, that is identification of the compound. What we have identified, X is phenol and Y is salicylaldehyde, that is the orthohydroxybenzaldehyde, and Z is orthohydroxycinnamic acid. So X is phenol. Through phenol, through the well-known name reaction, that is Reimer reaction. Y, that is salicylaldehyde, can be formed, and this salicylaldehyde, it has the CHO group attached to benzene ring. It can undergo Perkin condensation reaction, whereby it can give the alpha beta unsaturated aromatic acids, and both this phenol and this salicylaldehyde, they can undergo this coupling reaction and form the azodine. So this is the end of this today's discussion. Thank you.